Jack. I'm going to be presenting my research on the evaluation and qualification of anonymous communication systems, which I had the honor of working on with my professor, Dr. Alexander Correspondence. So first we're going to go over some key concepts before we delve into the methods that were used. First off is, what exactly is an anonymous communication system? An anonymous communication system is any type of system that aims to protect a user's anonymity and or security on a computer network. So we can see here a client needs to access a server, and the client would be you, and the server could be Google.com, Amazon, anything that you're trying to go through. And if you were to go directly to there, your identity is compromised because the server knows where you're coming from. But if you use a proxy or VPN here, then your identity can be preserved, and this is just one example of an anonymous communication system. Next is what exactly network traffic is and how it's comprised. Network traffic is encapsulated into objects called packets, which are sent across networks. This is how the network traffic is managed between computers, and it can be divided into two primary sections, the metadata and the data. The metadata can be thought of as an envelope around a letter, and the letter is the actual data inside of that envelope. The envelope gives information about where it's coming from, where it's going to, its sequencing, and a lot of other technical details that I'm not going to delve into. And the data is whatever website that you're coming from, that you're going to, data, text, files, anything that you want to send across the computer network. And the last thing is machine learning. This is a subset of computer science that allows computers to learn without being explicitly programmed to. So if you were to go on Amazon and search for a kayak, and then you go on YouTube later that day, and you see an ad for a kayak, that's machine learning at play, learning about what your behaviors are. Now, anonymous communication tools can be used for a variety of reasons. It can be used for good or bad. And the good in anonymous communication can be found for users hoping to circumvent oppressive regimes or hoping to keep their traffic private and secure. But it could also be used for malicious intents. So if someone wanted to hide their identity while performing malicious attacks on a network, they could be using these systems to hide their identity. But the general use of an anonymous communication tool is to hide the user's traffic and hide where they're coming from, for good or bad. Now, for the purposes of testing, we chose 7 applications, 5 of which are proxies and 2 of which are VPNs. The technical differences between them don't really matter because they accomplish the same goal. And for the purposes of this testing, we collected some preliminary results, and we only used 3 of these applications and 1 set of data that was unaltered traffic without the use of these systems as a control. Now, moving into our methodology, the first thing that we aimed to accomplish was an evaluation of each of these systems. And to evaluate these systems, we looked at first what kind of encryption it used and how strong that encryption was. Second, how flexible its protocol and how configurable it is. Third, what's the ability of the program to circumvent censorship tools that are currently in place? Fourth, how easy is it to configure and deploy these tools? Fifth, what kind of platforms can the application be deployed to? Sixth, how old is this application? And seventh, when was it last updated? Now for packet features, these are the things that we're going to be looking at from the data that's generated by these tools. And these are the key features that will be distinguishing it from other tools and will allow us to classify these applications based only on the metadata and not the actual data that the application is transmitting between 2 computers. We're going to be looking at this average packet size, the average packet frequency, how fast it's going in and out of the computer, the number of packets total that were transmitted between the 2 computers, the packet entropy, so how random that packet is based on if it's encrypted or not, the percent of packets that are coming into the system, and then the percent of packets that are going out of the system. So this is our testing environment. It looks convoluted, and it is in a sense, but essentially what's happening here is traffic that's generated by the host is passed from the client and through our AC system, the client here, which then forwards it through the switch connecting these 2 hosts and to the server, where it is then received and a response is generated and passed back. So they're just having a conversation with each other, and it's going through this anonymous communication system, right? And as this is happening, this conversation between these two anonymous communication systems, well then system as a whole, it's being captured and saved to a file. And this file is it's the data that's going through that network that we can then work with and extract features from. Now, after we have that file with our network traffic, we can parse out important features from it. And we can take those things I was talking about before, the entropy, the percent that are coming in, the percent that's going out. We can parse it with these applications, join, cap infos. And then with those parsed results, we can export those features to a file, acn.csv, the naming is arbitrary. And then we can have those features listed on a line with a label. Now, we're using 4 applications for our preliminary testing, and each application has 20 of the traffic flows performed on it. So in total, we have 80 instances, so 80 lines with the traffic features and the label corresponding. Now, once we have these files with the traffic features and the labels, we can then pass it through a machine learning algorithm, which can then learn the different types of systems, how they appear based on those traffic features, and then based on what it's learned, it can classify flows that it's never seen before. And so it can give you the label for those and actually tell you without knowing ahead of time what it is and where it came from, without looking at any of the data, just the metadata, what's around that data that's being sent. Now, for our evaluation, we found that most of the applications utilized encryption, so kept the traffic secure, and not many of them had flexible protocols. You couldn't really configure them how you wanted it very much, but that's not too important for the purposes of this testing. The protocols for these applications, some were compromised and some weren't. So if the protocol was compromised, that would mean if you went to China and you tried to use these to circumvent censorship tools, it might not work. So the ones that were compromised wouldn't be effective in remote situations. Ease of deployment, most of them were fairly easy to deploy and configure. They were available on a wide range of systems, and they were all fairly recently updated, so that they were new and up to date. Now, for our classification, using our machine learning model, we used 2 different algorithms, a J48 algorithm and a random forest algorithm. These algorithms are arbitrary. You could use other ones, but they were chosen based on their performance. They performed highly, and you can see with the performance metrics that J48 has very high accuracy with these performance metrics. I'm not going to go into detail on them, but they reflect how accurate the system was. And random forest also has very high accuracy. And looking at the percentage of the instances that were correctly or incorrectly classified, you can see that both J48 and random forest have high accuracy in classification. So that percent of the time, it was able to tell you what the application was, only looking at the metadata. Now, concluding from this, we can say that an evaluation about these applications' capabilities was successfully compiled, and with this evaluation, we were able to create a preliminary classification system to prove that anonymous communication systems can be classified based on only their metadata. And this could be useful in the real world outside of this convoluted virtual testing environment. This could be used in places like schools, corporate environments, where you may want to keep users from using these tools to circumvent censors. So they may be using it to access inappropriate content in places like schools, and you can use this to determine whether students are actually using these tools. And you can determine, only looking at what's around that data, what tools they're using, and you can cut it off if you need to or do what you want. It can also be used to improve on these tools by researchers. And yeah. In the future, we would like to collect some real-world data because the preliminary system is using artificial data generation. This may not be optimal for real-world situations and when you want to classify. And we would like to migrate the testing environment to accommodate the remaining tools and complete the testing. I want to thank the SRI program, Amy and Asfa. I also want to thank Ms. Jennifer Barreto for introducing me to the program, my mentor, Dr. Alexander Perez-Pons, and everyone else who has supported me up to this point.
So, you said you used 2 different algorithms and they're both pretty accurate. What does that mean and what does that tell us about these?
Okay, so it isn't necessarily tell us anything about the proxies, but in terms of the classification process of actually classifying these proxies based on their traffic, it tells us that the traffic that's coming out of these applications is able to be classified only on that metadata. So every application, when it communicates on a network, has very minute, slight differences in timings and latency. Yes, it's a thing, we call it fingerprints. So yes, it tells us that those applications have a specific fingerprint.